Oh, hello guys. Welcome to week two problem solving sessions. And this week is all about and direct kinematics and inverse kinematics problems, and also about some Jacobians problem. I think Jacobians problem, which you can easily solve those problems. Uh, these problems just you need to go through the lecture notes, and most of these equations has already been given to you. Let's say you have to find out this Jacobian and coordinates velocity and effector velocity. So this equation has already been. So I think this solution has already been solved, but you need to you need to use those equations which a professor has already given it to you, right? I mean, let's say for difficult thing be to joint coordinate system. You want to find the joint. Yeah. So like let's say for d tau by d theta, how to get like can get t equation like which is 0 t4. You can easily get it. Okay. You multiply this stuff, but how to get this d tau by d theta? So this you need to the lectures of there was equation by solving the equation. You need to use this formula how to get this theta by okay, how you will so all these equations have already been given it to you. You need to know how to this equation and so like I've solved one problem for you. It's the same problem of using DH parameter how to get the final transformation matrix and using this and if the defector position orientation is given to you get the joint it's that particular. So both forward and inverse kinematics have been solved. Just here's the first question. See, so you see a triple R manipulator is given it to you. Okay, and so there are three links. All three links are rotary links. Okay, so this is one of the question which I took it from a Craig book. Okay, and so first, in order to solve this type of a forward kinematics problem, we need to know what is the DH parameter. Okay, so there are different DH parameters like alpha, AI, and DI and theta, right? And these are a definition of how to get those DH. So before that, we need to first of all uh, get our coordinates straight, right? First of all, we need to set our z axis for each for different coordinates of each points. There are three joints, right? And if you are considering the base link also, then there are four coordinate axes. First of all, we need to find zi for each coordinate. Uh, so let's say, oh yeah, so we need to put each coordinate for each coordinate we need to zi. So for this one, let's say this is our base frame, so the axis will remain the same. So z our z naught. Okay, and for this frame, which is coming, what's in the joint axis is coming out of the plane, what z1 look like. theta 1 and theta 2. And again, this is Z3, sorry, Z2. Okay. And for this is our manipulator, our end effector, our end frame, or you can call it as a gripper. For most of the gripper, professor have told you that you need to take that axis always coming out of the upper axis. But here it's a different case here. Here you see the link 3, this is the link 3, and this link 3, the gripper is also moving with it. Whereas in previous cases, if you have seen, uh, professor in the last link, let's say for SCARA link, have that thing, right? This have this like rotation, and ultimately you will find then there is before having any gripper, there is always some kind of a prismatic joint is there. But in this case, it is not the case. Here you see there is a gripper which is also moving with respect to this. I have not specifically said it. Okay. So in the question, we need to find out the expression of x and y z. Okay. So we need to find out this x y z with respect to the base frame and in terms of the joint variables, right? So there are three joint variables: theta 1, theta 2, and theta 3. All the revolution. So the first you have to define this z naught. So in this case, let's in this case for a revolute joint case, we need to define z3, because z3 will remain same as for this joint and this joint. So this is a part of this link. Okay, this is a rigid link, right? Full link. So the axis also will be remain the same. Okay. So let's say this is Z2, then this will be Z3. Okay. And yeah, Z3, then all the axes, all, yeah, so we'll come to how to calculate X3. So after finding out Zi, need to move on to Xi. How to get Xi, right? So Xi axis for each, you need to use this formula. Okay. There's basically xi should be equal to xzi minus 1 cos zi, right? So let's say I want to calculate this xi for this one, right? How to do it? What you need to do, you need to cross multiply this z naught cross z1. So you need to use your right hand thumb rule, and whatever direction will pound, you need to mark the equation. So do the cross product, will get something like x1 here, right? This is the x1 you will get. Okay. And similarly, when you do it for link 2, you will get x2 here. Okay. And when you do it for z3 again here, so this case x2 and for z3 and z2. Okay. If you see z3 and z2 are the same, actually z3 and z2 are the same axis pointing uh, out from the plane. Okay. When there is a common frame, when there is a common axis, you need to move along the common normal. The x3 will be along the common normal. So this line which is going like this is for common normal. This is where x3 will look like. And using the right hand thumb rule, y3 you can calculate. So again, this is x naught. So, and for this one, so for base frame, you don't base frame will always mean the when you can take arbitrarily, but if you know x1 x2 x3, it's good that you will take along this x no x1 axis on it, and x1 always a good practice. Okay. So when you do this x naught x1 x naught x1 x2 x3, if you found that out, you need to get what are the y axis. So you can using the right hand thumb rule, you will get y naught, y1, y2. And if you got this thing, you need to fill those DH parameter table. Okay, how to fill the DH parameter table? So you need to please remember this for definition. And using the definition, we will fill this DH parameter. First, let's say we want to calculate alpha I. Okay, and an I is one, which is alpha one. Let's see what is the definition. The angle between zi minus 1 and zi measuring about xi. I equal to 1, zi and z naught measuring about x. So when you measure the angle between z naught and z1 is measured along xi, and when you use the right hand thumb rule, you'll see alpha 1 will be 90 degree. Okay, and that's the same for not the same, but for in order to put what is AI. AI is the distance. Uh, AI is basically the joint length, or sorry, link length. So distance between origin I to the point of intersection of xi and zi. This is basically your B professor was talking about. But instead of B, I have written it something like that. So first we need to find out what is the origin of I frame. This is our origin. So this will be O1. Okay, this is our origin, and we need to find a distance. First point we know. The second point we need to find out. What is the second point? It's the point of intersection of xi and zi minus. What is xi and zi minus 1? Okay, where is xi? This is our xi, which is x1, right? And zi minus 1, which is z0. Okay. When you join this line, when you intersect this line, you will get intersection at this point. And when you find the distance, this is O1 and this is O0. This is the intersection point. You will get something like L1, right? This is L1 is, and coming to di is the joint. It's a joint length. Okay, basically it's a variable, but you can directly write it because the revolute unit it is 0. But you can use the definition also. It's a distance between origin I minus 1, I minus, and the point of intersection of xi and zi minus 1. What is xi? This is xi and zi minus 1, which is 1. So xi and zi, when you intersect it, you will get the same point O naught. Okay, so and the distance is 0. Is 0, and theta is the angle between xi minus 1 and xi. So xi minus 1 and xi. The angle between xi and xi minus 1 measured about zi minus 1, which is this one. So I am not shown here, but this is not will not look the same here. Actually, it will look something like this. This is something like this. After this theta rotation, right? Will something after theta rotation, let look something like there is something like a angle is there, right? This angle is theta 1, which is theta 1. Rotation is given into theta 1. Now coming to the second link. In the second link, if you see, which is link 2, let's go to the alpha 1. Alpha 1 is the angle between alpha 1 is the angle between zi minus 1 and zi. Okay. So if you see this is z1 and this is z2, there is no angular difference. It's 0 here and measured along it. And when you do the same for so let's say calculate a2. A2 is the distance measured along x1, which is this long x1, and it is the distance between OI, which is this point, and let's say what is the intersection point of xi. And, this is the I point, and this is I minus. This is the intersection. This point is basically a link length, which is L2 here. And again, theta 2, you can find out theta 2 again the same. The angular distance between Z2 axis. So what is the zi minus 1? I minus how the angular motion carried out is basically theta 2, right? Z1 axis, right? Z, Z2 minus 1, which is Z1. Get this theta 2. And D2 you can easily calculate it. Again, it will both point get at this point. Coming to the last point here, this theta point, the theta. You will again see that Z2 and Z3 are the same. So alpha A 0, there is no angular difference. And again, the AI is the distance origin. Again, AI, yeah, A3. Again, A3 is the distance between origin in I, which is 3 here, is the origin. So 3, and this is 4 2. Xi and Zi minus here, here, 1 here. L3 here. Again, the difference theta, and will get how much station has been at Z2. In this way, you can calculate DH parameters. And after DH parameter, you need to use this formula. So please do remember this formula. Okay? Formula is by heart this formula. And so please, so in exam, you have to use your hand to do the pre-multiplication stuff. Okay. And since we want to calculate the position of the end effector, okay, and this parameter, this each, when you use this each parameter, will give something like for, let's say, for first link, it will give t01, will give transformation of a coordinate frame 1 with respect to the base frame. Okay, and you need to use those DH parameter, and you will get some kind of a transformation matrix. Okay, but if you want to, but in our question, we need to get at the last position, which is the tool position. For that case, we need to know what is 0 T3. So how to do that? You just need to pre-multiply stuff, right? You know, already know. But how to pre-multiply this stuff? Like I've uh, I've made a MATLAB code which do this stuff. So that's that code, I think. So in the MATLAB, I've programmed yeah. So I've made a program which take DH parameter as input, and you will get those transformation methods. Let's just go over this program. So this is a program, simple program. This is a sims, which is some kind of a symbolic program. So L1, L2, L3, these are the different uh, these are the different link length, and this theta 1, theta 2 are the different joint angles, and this D1, D2, D3 are the joint distances, right? And these are DS parameters. So like so you can change this DS parameter according to a specific, but please do remember that you need to also you need to also add those parameters, right? So this parameter, so this DH formula, I have made it for n degree of freedom, and so here you just need to add all these parameter in terms of their value. So let's just say, for in our case, there are there are three links, right? 1, 2, 3, alpha, AI, DI, and theta I, and you have alpha, A, D, and theta. So I made some kind of a vector here. So uh, there is this DH parameter, alpha 90, 0, 0, right? So for three link, alpha is 90. So for one link it is 90 degrees, second link it is 0, third link it is 0. A is L1, L2, L3, link length, offset, and theta. Okay. So these are different. So you need to give thing as an input. I've already given it. You can also change it. So I've also added the last slide. I've also added this MATLAB code, so that you can easily use it. Okay, if you want, you can use ChatGPT to convert this into a Python code. Okay. If you don't have any access to, let's say, MATLAB, what you can do is like you can code to a ChatGPT and tell them to convert it to a Python code. Python is an open source software, so you can use that. Let's just get back to our question. So this is for three links. What you need to do is you just need to run it. Okay, I think okay. It's a box error. In problem which, let's hope it will yeah, you see that. So you see there are different in the workspace. You will see there are different uh, variables are there, and if you, there is this symbolic terms are there. So there is t. So if you remember, so this see the command window, how you will look. So it's T01, T02, T03. Basically, it pre-multi. So it's a link one with respect to base frame, link two with respect to the base frame, link three with respect to the base frame. So they have already solved the whole equation for you, and they have. And if you see there is this cos theta one pi by 180 is basically to convert the degree to radian value, and then there is L1, L3, pi theta 1, theta 2 plus theta. This is so they have already given you the whole formula. Okay, you if you want to get uh, each and every if you want to get each and every link homogeneous matrix with respect to the previous link, you just need to type T here. So if you type T here, they will tell you there's a homogeneous matrix. Like, so there are three links. So there are three transformation matrix with respect to their previous link. And you see this is T01, and this is T02, and this is T03. Okay. And so no, sorry, it's T01, it is T12. It is T12 because the frame 2 with respect to 1, and this is T3, right? And if you want to calculate T03, you just need to pre-multiply T02 and T01, right? So let's just come back to our question. So using this formula, I have formulated this T01, T02, and T03. And in order to calculate the last frame, I just need to pre-multiply, post multiply in this. Yeah, so T01 post should be post multiply by 1, 2. And so we need to post multiply here, not pre-multiply stuff. Okay. Why post multiply? Because we are moving with respect to the current frame, not with respect to the base fixed frame. And when you do this thing, this is what you will get here. So it's zero. This will be your final equation. I think if you go to MATLAB, you will get the same equation here. But when you run the program here, so you can also do what you can do is like just need to make T01 and make your own thing like 02. So I will this one. Yeah, I think 1 3. So if you know what is so 3 is you by t so 1 divided by t 1 2 divided by it, the long form which you get. What you can do is you can just need to first of simplify 3 for you. You will get something. And if you compare this thing with that equation, you will get the same. So you can use this formula, you can use this code anywhere. Okay, but if you just use this code, they will just calculate the whole thing. So 1 t 0 to t. And this is a so you can do it for any number of links. Okay. So in this case, I have like 5, but if you want, you can add L6 also. You can add many more things. You can add. Okay. So the code which I have added this code here. You just need to copy paste it, and if you want to convert it into Python, please. And let's move on to our next part, which is I think inverse kinematics. Okay. So the next question is, let's say if I give you so let's say I give you this is our in the inverse kinematic. Let's say I have given you the orientation of this like the position x y z, and along with that, let's say px py pz is the position of the gripper with respect to the base frame, and which is px py pz, and r1 r2 r3. So all this whole matrix is given it to you, and they want you to find out what is theta 1 theta 2 and theta 3 in order to reach that point. That is what the inverse kinematics look like. And so let's start the thing. So how to calculate the c1 c2 c1 c2 not c23 is basically cos theta 2 plus theta 3. Yes, s23 means sine theta 2 plus theta 3. Okay. And this was the equation. And coming to the so first we in order to get theta 1, how to get theta 1, what they have, they divided 1 3 by 2 3. What is 1 3? This is 1 3 row 1 third column, and this is 1 3 and this is 2. You divide this thing, get something like a tan inverse, right? A tan theta, right? And when you just take that tan to the other side, it is tan inverse r13 by r23. So theta 1 you got it. Next task is to get theta 2 and theta 3. How to do it? Equate 1 4 and 2 4. What is 1 4? This is 1 4. So need to look into 1 4. What where is 1 4? This is 1 4 and this is 4. Just equate it, and you already know theta 1. And let's say to take c1 common, s1 common here, right? So that's what they did. They take c1 common, s1 common, and they've equated to, let's say, px and py, which is here. And you just need to, I think you can divide this. So what you have done is like they have done here is c2. They find out c2 here. Px by c1, they took it 1 here, then minus l1, and so they got c2 two different equation. This is the one equation and this is one equation, and c1 is not equal to 6, c1 not equal to 0. So you took c2 here, and so they find out c2 here, and how do they do it? So this is a c2 here, and then there is something called pz by pi. So what they have done here is they know what is pz is. Pz is equal to 12. Z is equal to, and yeah, what they have done is they have calculated this H2 is equal to Pz by, so you know H2 here, and you know something like C2. So H2 by C2 is tan theta 2, and when you take tan to the other side, it's tan inverse, get theta 2. And for theta 3, just need to equate C1 and C2 is this part, C1 and C2. Okay, uh, oh, sorry, this is 1 and 3 2. The 3 1, this is already know. Just need to the, so this is how you solve the equation. And let's say the tool position is only known to you. Instead of so let's say they haven't given you the orientation matrix. So like if the tool position is only given it to you, so they haven't given you the whole matrix, like whole transformation matrix with respect to the base. So they have already given you this thing, px, py, and pz. Okay. And you compare it with your so you get the transformation matrix, and you compare it with those point here. And based on that point, you now want to calculate what will be the different theta 1, theta 2, and theta 3. So again, so you have this equation. You take S1 common here. And equation you take C1 common here. Get something like this. Just uh, divide this S1 and you get a tan inverse thing, and the one you can. Now you need to define something like an alpha here. Where alpha is how you define alpha. It is something like a px by c1. Px, take c1 common, take c1 here, and L1 is also here. Alpha is basically alpha is alpha is bas- this alpha you can get it from both equations. That for the alpha, then this is like how alpha look like. This is alpha and L2, and this is alpha. You already know the last equation. And now to get this equation, what you need to do is you need to square and add things so that those cos square plus sine square term will become one. Square and add sum. This is what you will get. Cos square or pz square in the left hand side. You will. So if you see, if you so like you need to use that formula, right? For same answer. For this, so something like this will turn up sine two, like cos cos two cos two. Three is theta 2 plus theta 3, right? And cos theta 2. something like, so you will get something like this equation. You do the square and adding stuff, and you need to use this formula, and when you use this, then uh yeah, 2 cos the 2 plus the 3 minus the 2 will come, and the 2 theta will cancel, and the theta 3 will remain. What equation will, and again do the thing here. Alpha, you know, alpha bx c1 l1, you know, right? You will calculate. You get c3, then s3 will also be calculated. Square plus cos square equal to one formula, and we know c3 and s3 get theta 3, and if you get theta 3, finally in this equation you will get theta. But if you look closely here, see there are something like you are getting some kind of a two solution here, right? This case px by py, but you can also get the same for minus px and py. Let's say this is px plus py, this is, let's say this is, but you can also get the same equation like when you something like px and py, so again that different solution. For this case, we're getting s3 or 2 s3 value. If you do this, then there is a theta which is positive here. You take positive sign, and then take negative one, it will be negative component. There are two theta terms which you are getting. Similarly, so there are two terms for this, and if you do this thing theta one, you will get the same term for this one. So here also there will be two theta one. So one theta one will be 180 plus thing, and one will plus theta, and other will be, let's say, only. There is always a difference. So there are two theta 1 and there are two theta 3. So there are four combination can the which you can reach at that point. This is what multiple solution look like. So in inverse kinematics, if you know the position, there are multiple solution for this question. Okay. See that there is this theta 1, let's say 0 here. Here it is, let's say 180 degree. So using this method, you can reach at this position by different means. You see the orientation quite different here. So in like this, the orientation of the bar is something like this. When you go it something like this, the orientation look like something. Okay. You see here we have only known the position. If you would have known uh, the orientation also, the orientation of this tool, then there might not have been a problem. That case, you will only get one solution, something like. So that is the case with the inverse kinematics. You will get multiple solution, whereas in case of forward dynamics, you will only get single solution. Okay, and let's just move on to our. So there's a concept called workspace. That I have not solved you, but just please do listen for your. It's for your curiosity, right? It's not for your curiosity, but if in future if you want to, let's say, design a robot, or like design a robot on computational basis, need to see, right, what is the workspace is basically how far and how small places, what is the area that a robot can cover. That is the definition of a workspace is. So let's say find the workspace. Basically it's tell you to find out what is the area or a volume, a manipulator, so here in this case it's a 3 degree of freedom. So it be a volume, right? The 2 degree of manipulator, then it's some kind of a area which we want to. So let's just see to plot this. This is my pointer, and yeah. So we have L1. L1 is the link one, the bigger link. and this is L2, and so all this diagram will satisfy this constraint L1 and L2, so L1 L2. And we want to know what is the workspace, how much workspace it can cover. So when we want to calculate workspace, we need to use this theta one wholly. What is the how much theta one can go, right? Theta one can take from 0 to 360 degree, right? So it will be something like it can cover something like whole. And if this is also a planar thing, so this is also this is something that it will cover something like also, but the circle it will cover is in z and x plane, whereas the previous one it will cover in y and x. And if you draw the same thing for the last thing, so yeah, so when you so this is the workspace for when you do this for, so let's say if you're this is what, so when you do something like this, you need to like this, you need to reach to its maximum position. In this case, this is one, this is L2, sorry, this is L3, this is L3, this is L2. The yeah, I think so. It will form something like a toroid. So when you draw something like this, so first of all, this will remain the same, but thing like this, get to see this L3 and L3. So they have given it. So when they want to know what is the workspace, they want to also know what is this area or what is the volume of this. Get the picture like how it can do the circle which it can move, and this is a circle which other can. Okay. In this way, you need to find out what is the workspace, what is the volume. Yeah, I think that's it for this session. If you have any question, please do ask. And these, so you can easily solve this question. Most of these questions are formula-based questions. Okay, you can solve this question. Yeah, I think that's it for today's session. Till now, we will meet next week.